Welcome to Anything Maths. If you find this video helpful, by all means give it a thumb up. The video is all about indices. So let's get right into it, shall we? We're going to start with the laws regarding indices. So let's look at the first law. A raised to the power m times A raised to the power n is given by A raised to the power m plus n. Now, when you look at this law carefully, on the left-hand side, we have two indices, but they have the same base, being A. And these indices are separated by the mathematical operation, multiplication. And if this happens, the rule or the law says, maintain the base and add the two powers. That is why we have A raised to the power m plus n on the right hand side of the equation. What are you going to do now? We're going to look at some examples that can help us to understand this rule better and also how to apply or implement this rule. Examples. Example 1. 2 raised to the power 3 times 2 raised to the power 4. Here we are dealing with the base 2. So write out 2. We have 2 powers, 3 and 4. 3 plus 4. 3 plus 4 is 7. So 2 raised to the power 7. The second rule. Y raised to the power 2 times y raised to the power 6. The base is y, so y raised to the power 2 plus 6. 2 plus 6 gives us 8, so we're going to write y raised to the power 8. The third example. 4 raised to the power negative 3 times 4 raised to the power 2. Now be careful when you are dealing with negative numbers because you can easily make a mistake. It can trip you up. We're dealing with base 4, so we put the 4 down. We have negative 3 plus 2, and that will give us negative 1. So 4 raised to the power negative 1. Looking at this example, it is quite clear that applying the first law of indices is not all that difficult. Let's have a look at the second law. The second law. A raised to the power m divided by A raised to the power n is given by A raised to the power m minus n. When we compare this law with the previous ones, we can see that the difference lies in the operation, isn't it? The mathematical operation. This time we have division. And if that happens, instead of adding the powers, we're supposed to subtract. We're going to consider some few examples that can help us understand it much better. Examples. 4 raised to the power 6 divided by 4 raised to the power 4. The base we're dealing with is 4, so we put the base down. We have powers 6 and 4. You have to maintain them. So the 6 come before the 4. So it's supposed to be 6 minus 4. Don't change the positions. So it's going to be 6 minus 4. And 6 minus 4 is 2. So 4 raised to the power 2. Second example. T raised to the power 2 divided by T raised to the power 5. The base is T. 2 minus 5. 2 minus 5 is negative 3. So T raised to the power negative 3. The third example. 6 raised to the power negative 1 divided by 6 raised to the power 4. The base we're dealing with is 6. We have negative 1 minus 4. And that will give us 6 raised to the power negative 5. Why? Because negative 1 minus 4 is negative 5. This example shows that if you take your time and look at the laws and the examples, there's no way you can't do any question that involves these laws. It's not difficult to implement them. Let's have a look at law number 3. Law number 3. A raised to the power m or raised to the power n. And this can be written as A raised to the power m times n. And this is given by A raised to the power m n. We're going to consider some examples. Y raised to the power 2 or raised to the power 3. And this will be y raised to the power 2 times 3. 2 times 3 is 6. So y raised to the power 6. The second example. 6 raised to the power negative 3 all raised to the power 4. We're going to have 6 raised to the power negative 3 times 4. We're going to be 6 raised to the power negative 12. Third example. 2 raised to the power 4 all raised to the power 2. We're going to have 2 raised to the power 4 times 2. 4 times 2 will give us 8. So it's going to be 2 raised to the power 8. This is how we can implement the third law of indices. Let's have a look at the fourth law. The fourth law of indices. A raised to the power negative n is the same as 1 over a raised to the power n. Some examples will help for better understanding, isn't it? So, examples. Example 1. 4 raised to the power negative 2 is the same as 1 all over 4 raised to the power 2. We could have written this as 1 over 60, but we're leaving everything in the form in the meantime. So we have y raised to the power 4. This is the same as 1 all over y raised to the power 4. Ten raised to the power negative 3 is the same as 1 all over 10 raised to the power 3. Once again, we can see that these laws are not really difficult to apply. This brings an end to the first part of the video. If you found this video helpful, give it a thumb up and look out for part 2.